Let's start talking about pennies a little bit before we get into atoms. Okay? Let's take a look at these 5 pennies right here. They have a mass of 15 grams. That's 5 pennies at 15 grams, so that works out to 3.00 grams per penny. All right? Let's take a look at these 5 here. They've got a mass of 12.5 grams. That means if we divide it by 5, that gives us an average mass of 2.50 grams per penny. Now, what's going on here? They both work the same. If I take these pennies to the grocery store, I can purchase as much with this penny as I can with that penny. Yet there's a half a gram difference. Well, it turns out in 1982, the price of copper became too expensive to make pennies out of it. So they changed the inside of the pennies. They are no longer pure copper. Okay? So where does that lead us then? It leads us to, let's take a look at this. Press 0 there. Now, if we have 10 pennies today, 10 pennies has a mass of 26.7 grams. That means that there's an average mass per penny of 2.67 grams. That number is between 3 and 2.5. Well, why is it? It's because 3 of those pennies are from before 1982, and 7 of those pennies are from after 1982. So we get an average mass of a group of pennies that is between these two numbers. So now, what about atoms? Okay, so now let's talk about atoms and see what these pennies have to do with the atoms. Atoms, as you know, have a nucleus surrounded by electrons. This is going to be our nucleus for an atom, and this will be a nucleus of another atom. Okay? Now, there's nothing in the nucleus right now. Now, the atom that we're going to be interested in is going to be nitrogen. And if you look at the periodic table, this is what you'll see. There's a 7, and then the elemental symbol, and then this weight number. Okay? The 7 tells me that there must be 7 protons in the nucleus. So here are 7 protons that we're going to put into that nucleus. Now, these blue marbles each represent 1 proton. Okay? They have a positive 1 charge and a mass of 1 each. Here's our other nucleus. Okay? Again, it has to have 7 protons to be nitrogen. If it has 6, it's carbon. If it has 8, it's going to be oxygen. Now, in the real world, there are some nuclei of nitrogen that have 8 neutrons in there. Now, the job of these neutrons is to hold the protons together, because you know that likes repel likes. So all these positive charges in there would be just blown apart if the neutrons weren't somehow helping hold them together. So now this is a nucleus of nitrogen, and each of the neutrons also has a mass of 1. So there's 15 in there, so we have a mass total of 15. Okay? Now, other atoms of nitrogen in nature only have 7 neutrons. So this is what a nucleus of that kind of nitrogen atom would look like. Okay? To have 7 protons and 7 neutrons. We can write that as nitrogen 14. Okay? Or you might see it written like this sometimes. It has a mass of 15, and there are 7 protons. So you have nitrogen with a mass of 14 and 7 protons. Well, where did we get this number from? This number lies between 15 and 14. Well, in reality, there must be a lot more of this out in nature. Just like with our pennies, there's more of the after 82, so that puts the average closer to this number. Okay, and our average here puts the answer closer to this number. And that leads us into, these are isotopes of each other. The prefix iso means the same, like isosceles triangles have the same length of sides on a triangle. And isometric exercises, you're pushing together your hands or something with the same amount of force. So these are isotopes. And now go ahead and please watch Dr. Slaybaugh's Subatomic Particles video lecture.